We are Team DS. This is David, Sarah, and I'm Sumner. We are working on the distillation column. So what is distillation? It is you separate mixtures of two or more substances in different levels of purity, and by applying or removing heat. Kind of clever picture there. It's the most common separation technique for separating mixtures, but it consumes quite a bit of energy and can consume more than 50% of a lot of plant operations for their energy costs. There are two types of distillations: there's batch and continuous. And batch distillation, you're distilling in batches. You must recharge the still after each distillation, and is commonly used in distilling spirits, different liquors like whiskey. Continuous distillation, there's no interruption. You just continuously feed in your mixture into the still, and is commonly used for crude oil. Here's an example of a batch distillation. Here they're distilling whiskey on the right, and it's called a pot still. They have a furnace on the bottom, heats it up, and then shown on the right cools. They're pretty massive. And then here's an example of continuous distillation for crude oil. It's much more complicated, but they're able to get a lot more out of it continuously. You can see the different levels. They get the diesel, oil, kerosene, the gasoline, and then they continue to use the heavier stuff at a lower pressure fractioning tower. And on the right is an example of a crude oil distillation refinery. This is our distillation column. Thanks to Team Blue from 2002 who made it. And as you said, it's set up with our reboiler at the bottom, and we have 12 trays with the feed in the center and the reflux and the condenser at the top. We currently run it using batch distillation, but it can be set up to run continuous.
And this is our distillation column. This is the reboiler with the bottom 6 trays on the left side. The right side is where you insert the water, methanol, or ethanol, or whatever compound that you're mixing in it to heat. This is an example of the pumps that we have at our distillation column. They're peristaltic pumps. Only one of ours is currently working right now, which is the one on the right, which is blown up on the right side of the screen. And the picture below it is the back. The picture to the left is demonstrating how it works and how it pumps the water throughout the distillation column. The cooling water valves are right here on this picture. We've had some trouble with keeping them at a certain angle, which provides us the certain cooling water speed. We've had some, at the beginning, one of the difficulties we ran in with was Dr. Murad and the other junior lab, or some of the juniors kind of messing with that, and anytime we calibrated that, we'd have to either recalibrate it or just disregard it all in general, which was one of the frustrations we had at the beginning, which was why we weren't able to get as much done in a fast amount of time as we had liked. These are the trays. The ones on the left side of the screen are the ones that are at the top on the second level of the lab, and then the one on the bottom are the bottom 6 of the 12 trays. And then to the left, in this left picture, is where the distillate is gathered, and then you can see the mass tray right there that gathers the information about how much distillate we receive per reaction. And then on the right, that yellow knob right there is the flow meter, which has also been giving us some trouble throughout our weeks with this distillation column. This is the place where we gather our distillate, and this is the flow meter, which is not working. We've tried to follow the wires all the way up to the electrical board at the top, but since we are not electricians and we got lost along the way several times, that came to no avail, and we tried looking up some new flow meter pumps online and suggested them to Dr. Henry, but it is still not working. This is the top with the condenser, and then the other cooling water. And that's the back of it on the right. And this is the upper condenser, obviously, and with the cooling water valves going through it as well. This is the reboiler heater control. We've been having some difficulty with this as well. Sometimes it operates pretty well from the computer, and then sometimes it randomly has to be operated manually. And by flipping this knob right here, it goes from manual to computer. Last week it was working through the computer, and then it's randomly decided to be run manually, and so that has also been an issue for us. This is where you turn the reboiler power on, obviously this lever right here, and then this is what's been acting up periodically with running it manually or through the computer, the wattage on the left of that. This is the interface, as you can see, with David so eagerly working on it. This represents everything that we're able to control from the computer. This is the part of the power that we just saw in the previous slide that's been randomly with manually and computers, so we've had some difficulty with that throughout this process. The feed pump, this is the only pump out of the three that you saw earlier that does work and does pump through here, through the trays. This is obviously the reboiler, and then this represents where we get our distillate, and as we gather grams of distillate, this will rise, and you can see that there. This is the temperatures of the trays, and you can see that throughout the experiment as well. And some of the difficulties, as I've already mentioned, most of them, has hindered our ability to attain data in a timely fashion. As I mentioned, the reboiler power sometimes varies between computer and manually. The cooling water valve, that did randomly start, well, not randomly, but people were starting to mess with that some at the beginning, so that was a frustration. And the flow meter does not work and has not worked. Then at one point we were locked out of the distillation interface. Dr. Murat started messing around trying to fix some stuff on it, and ended up just kind of messing up even more. That was already messed up, and then David couldn't run the distillation column remotely, and that was a little frustrating for him. And then at one point one of the condensers was leaking from the tube connected to it, but we got that fixed. And then one week we just had a bad attitude, but we fixed that, and thankfully we were last week going to recommend that we be taken off the distillation column, and we didn't think that we'd do anything else, but we fixed our attitude, and now we were actually able to attain some data. So if you want to go ahead with that.
One of our two junior teams is a team purple, and they have been working on various maintenance issues. So there was a kink in the cool water return line, which they were able to straighten out and redo how it was hanging. And they also did some labeling for us, and have calibrated the cooling water once, but again, every time you adjust the valves, it's different. This was this was the first time we actually had them operate the column. This was just with plain water, and just wanted them to get familiar with the controls and be heated up, just to become familiar with the system. And this is our other junior team, which is also, of course, a senior team, and they have also performed various maintenance issues, and have done one really good experiment, especially to study the heat loss of a column, where they were here all day on a Saturday to run it. And that's the one where they started at 330 watts in the reboiler power and then stepped up by 200 watts all the way up to 1,530 watts. And then started the step down, but it worked out really well. This was a cooling curve I made right back at the beginning of the project. This was just with the column sitting idle and cooling off from just over 89 down to about 82.5, and we calculated that it loses about 0.35 degrees Celsius per minute. And based on that, we calculated that the heat loss from the reboiler just sitting and cooling is about 330 watts, which using the maximum watts with the reboiler set at maximum works at about 14% of the heat loss. This is the results of their 700-minute experiment where they started at 330 and then stepped up by 200 watts to get up to 1530 and then stepped back down. The tray temperatures for that experiment, to me the most notable feature is how once they get up to this maximum, it just the line representing the reboiler temperature is right here. So as soon as they start stepping down, the temperature starts dropping. So that again is part of understanding or attempt to understand the thermodynamic properties is that it appears, and we need to do further experiments, that's probably the minimum amount of power it takes just to keep the column hot all the way up and down so that it's still 100 degrees in the, sorry, I said reboiler, I meant the reflux temperature here. That's right. Here. See, it starts stepping down as soon as they step down from 1530 watts. And so they have also, we finally, just this last week, started running some batch distillation so that we could actually separate a two-component system. And the first one to run a batch was Team Black, and we had them run a batch at 1,600 watts reboiler power, and they added about 600 milliliters of methanol, which is about 475 grams, at 0% reflux. And these numbers were based on some other experiments that we found that they do, I think every year with another university where they run a large group of distillation. So we wanted to run it, use similar numbers so that we'd have something to compare to. And there's their tray temperatures for that batch. I think one of the things you'll notice is how it'll come up to just above 90 and then just gradually slope up as the methanol is removed. And this is what a plot of the actual distillate collected looks like, because as you can see from the picture before, the distillate is collected in a measuring cup that is on a scale that is also connected to the computer. So what happens is that you have an amount of material left in the measuring cup that's up to the outlet. The outlet runs down to a solenoid valve that is set to open once the scale reads 400 grams. And so as the distillate is collected into the cup, you collect it over versus time in minutes up to 400, then it dumps back to just whatever's left in the cup, which for most of these turned out to be right around 80 grams, except occasionally you get ones that for some reason dip below. But then this is when another issue with the overall column cropped up, is that you had this anomaly here, which happened at about 172 190. So for about 18 to 20 minutes, it was just draining. I think the valve had failed to close, and so as they were collecting distillate over this time, it was just running out and through the drainage hose through the bottom until Sumner was there with them and was watching it, and he just kind of tapped on the valve, and then it started collecting again. One thing to notice about this is that it dips all the way down to about 50 grams instead further down than these other ones. And so the same thing happened at the end of their run. And they collected a total of about 3,400 grams, which of course is mostly going to be water because there was only about 475 grams of methanol in the reboiler. So Team Purple, we have them do a similar run, again 1,600 watts and 600 milliliters. That should be methanol. And you see their temperature profile looks pretty similar to the other one, except they had even further issues with the distillate collection. I'm not really sure. I was going to actually include that, but I couldn't make. I'm still not sure what exactly was going on with theirs. I think they started maybe adding it, like their instructor had started adding distillate to it or taking it away because it never even got up to 400 grams. Also, partway into the run, he decided to take the power from 1,600 watts up to 2,300 watts, and so you see this little jag in it where they up the reboiler power. So to investigate what was going on with the column, I came in yesterday. This one was done yesterday morning. Decided to go with 1,500 watts because based on the other batch distillation, I wanted to kind of keep the temperatures down a little to see how that affected the rate of collection. But I also started with 13 liters of water, 720 milliliters of methanol, and operated at 0% reflux. And one thing I would point out from this is that you have the same kind of profile. This goes up and settles right around 88 degrees, but if you look at the distillate collected, it starts collecting distillate at around 70 something, and then goes up, reaches a steady state around in here, then gradually climbs as the methanol is. And so this is pretty similar to the profile for the distillate that I found with Team Black's results. The same kind of anomaly. This one was only about 4 minutes, but sitting and actually watching it, and because I knew to look out for it from the other results, and so I went and tapped on the same valve and then get the collection again, and I left the lab and went to class at that one. So the same thing happened at the end of this run where the solenoid valve or some other issue was causing it to just drain instead of collect. So also can see that based on the slopes of these lines, plotting them as the grams versus time, start with a little over 15.5 grams a minute, gradually slowing to about 14.5 grams a minute. So to summarize that distillation, put about 570 grams of methanol, dumped about 2,000 grams in about 190 minutes. So I averaging the rates, I get about 15.2 grams a minute of distillate collected. I'm looking at the amounts distillate dumped and trying to kind of interpolate a little. I get 1,640, so I ended up with a difference of about 140 grams. So I'm estimating that's about what failed to be measured, and it started refluxing at about 70 degrees, and the temperature goes up and stabilizes, and then gradually increased to about 95 degrees by the end. So that is where we're at with our experiments. We would like to do more to further it, understand the column, because every time we start to kind of get some consistency to our data, we end up running into another mechanical issue. And so we've just now started doing the batch distillations and the analysis and figuring out the way to approach the analysis to those. One of the things I thought of when we were looking at this is that if we could collect these at a reasonable period individually, then you could measure the densities and maybe get the composition at each of the little batches, and that would be, then you could try to look at the composition versus time. And it's something I didn't really think of until I started running the batch distillations. We are continuing to troubleshoot the actual operation of the column. There's still unresolved mechanical issues, and instructed the junior teams on how to operate it, how to run the batch distillation. So I would definitely like the Team Purple to rerun their batch distillation to see what exactly went wrong with theirs.